let's do this. Count and say. The count and say sequence is a sequence of digits, strings defined by the recursive formula. Count and say 1 is equal to 1. Count and say n is the run length encoding of count and say and compression method that works by replacing consecutive identical characters repeated 2 or more times with concatenation of the character. Concatenation of the character and the number marking the count of the characters. For example, to express the string length. For example, to express the string that we replace the 3 with 2 3s. Yeah, there was a riddle that was based on this. We replaced 3 with 2 3, replaced 2 2 2 with 3 3 2, and replaced 5 with 1 5. Yeah. Thus, the compressed string becomes this. So 2 3s, 3 2s, 1 5, and 1 1. Yeah. Given a positive integer n, return the nth element of the count say sequence. I wonder. So the sequence is going to be up to 30. I wonder if you need to actually determine. I guess maybe you don't need. So let me think about this. The nth element of the count and say sequence. So the count and say sequence will always have an even number of values, I want to say. The actual sequence itself. So if n is an odd number, it would return the frequency of some, like if you think about that sequence as coming in pairs, the first number that pairs the frequency and the second number is the actual value, the thing that's being repeated. So, okay. So if n is odd, dealing with the frequency of pair. If n is even, dealing with repeated value of pair. The value that is repeated. So I think this should be pretty straightforward. Could also actually construct it pretty quickly. I don't know if constructing it is any slower than actually finding the nth element. Okay, so let's go ahead and just determine which pair it is. So the actual, so if I think about 1, 2, return the nth element. For example, thus the compressed string becomes this. Return the nth element. N is 4. Output is 1 2 1 1. Input is 4. Oh, this is actually recursive, isn't it? Oh, yeah, okay, so count and say 1 is 1. Count and say 2 is 1 1. Oh, okay. So you kind of need to know, I thought this was different. I thought it was the nth character within some input count and say sequence, or some input sequence that you may count and say off. Okay. Interesting. So I wonder if there's a way that you wouldn't actually be Would you actually need to generate all of them? I guess you. Okay, let's try. Okay, we'll try the basic approach. Generate all sequences. And here n is 30, so I think you could probably do a call stack of 30 size. So we'll just do straight recursion here. Do you want to do straight recursion? N is 1. Okay, I'll try to figure out if I need to do more than. In theory, follow-up, could you solve it iteratively? Okay, maybe I can just do the follow-up. So I'll just use a for loop here. So case, let's say string is CAS string is going to be 1. Do you want to start with 1 because everything else starts with everything else is doubled is 2 characters. Actually, I think it's better to have an array of integers. And say if n is equal to 1, then we'll just return 1. This is a trivial case I don't want to deal with. The more general case would be, let's say digits is 1, 1. And for k in range of n, where k starts with 1, I think. So if n is 1, then you don't want it to go. If n is 1, no, that's right. If n is 1, then you want to do this at least once. If n is 1, you don't want this to do it at all, because digits is correct in that case. If n is 2, then you want to do 1 iteration. Okay. So if k goes from 1 to n, I'll say next digits is an empty array, and then I think I use a stack. All right. Do I use a stack? I don't think I need to use a stack. For index in range of length, I'll say size is the length of digits. If I were to go through all the indices of my current digits and basically keep track of the streak. Let's go. Streak is currently at 0, and value is currently, let's say, -1 to make sure it doesn't work initially. So let's say current value is digits at this index, and maybe I should set it to be the first value of this array. So streak is currently 1, the value is currently whatever the first value of digits is. For each index in range size, let's go with everything after the first digit. So if the digits at this index matches the current value, then increment the streak, else we're going to reset the streak. So streak back goes back to 1, and the value becomes whatever this current digit's value is. And when it resets the streak, it needs to append onto the new streak. Next digits dot append both the streak that was created, that was broken, the length of that streak, and the value that was used for that streak. Okay, then it resets it, then it stores the new value. Okay, I think that is correct. Let's go ahead and just and then after this digits becomes whatever next digits is. I think I should make sure this works. Index out of value in digits at 0. Digits at 0 should be 1. Length of digits. I must be storing this incorrectly somehow. Next digits. Oh yeah, next digits must be like not actually getting anything. So does it correct the first? Well, it doesn't do it correct the first time. The first time it should make it 2-1, I want to say. Yeah, it should be 2-1. So what does it do? Oh, it doesn't do the very last one. So if it's all ones, then it just, this current streak is whatever. Okay, this should be next digits, append the last streak, and next digits, append the last value. Okay, 1 1 2 1 1 2 2 1 2 1 1. Okay. And then at the very end, you should just return the concatenation. So join the concatenation mapping to string my digits. This is one off, I think. This should be n is 4. If n is 4, okay, yeah, this should be, if k is 2, 1 to 2 iterates once. Okay, I think it should be, k should just be -2, I want to say. If k is 2, then it never iterates. Or should never iterate. Alright, sweet beans. I wonder if there was a way to, in theory, you could actually just store all the 30 answers, 30 strings in an array and just say return hardcode the answer. Alright, but this is pretty good. Okay. By the way, the syntax here for the conversion of the integer array to a single string is you use mapping to convert to a certain type something, an array or list of a certain other type. So mapping to string all the integers in this array digits, and then from that mapping, which basically creates a collection of character digits, you join the characters with no spaces between them. The other common thing that you would sometimes do would be, yeah, this is pretty common actually, creating a string from digits. The other thing that you might want to do is convert a number string, a string and a number, like convert quote 1211 to an actual array of digits, and it'd be like that would be something like list parentheses map to integer the string, whatever the string variable is. Okay. Anyways, summary here. So this was like the iterative version of creating the creating the array of digits for input n. Normally you do this recursively, like in recursion you'd say what the base case is, like if n is 1, then return 1, and then the recursive case would be like, so for comparison, recursive case would be, this is probably not going to be super precise, something like you have your base case stuff, which is like if n is 1, return just 1, and then you have your recursive case, which is if, well, you don't need an if at that point. You would say, you might need a second function because the function would probably want to use an array. You could use a sub function that is the recursion function, where you have an array as an outside variable that you're iterating with. Nah, I think it makes more sense to use recursion where you have a function and one of the parameters is the array or one of the parameters is the current string. So like if you have, let's say you have a function where the current string is a parameter and your n value is another parameter. Then if n is 1, return that. Otherwise, you'd do something like, you would parse the current string, creating a new string, and then call to return the next iteration. I guess if n is 1, return 1. I guess the other base case is actually if n, I think here the recursion would be recurse function here. Maybe I should have just coded this and rather than try to explain it through a comment. K is 1, return. No, the base case is not like this, I don't think. Well, it could be like this, but if k equals n, then return the current string. And then otherwise you recurse where k goes upwards. So like, you have to parse the current string using a for loop or index in range of the length of the current string. Now you do a bunch of the blah blah blah. So then you have your generated string, and then you do recurse function of your new string, and then k plus 1. In any case, this one is doing something similar that you have your current array, um, go through all the indices of that array, keeping track of the streaks that you see. The way that you generally keep track of streaks is you either set your initial streak to be 0 and have some value that cannot be possible, so that you kind of reset your streak there, or you have your current streak be 1 and your value be initially your first value in it. Was there a way to actually maybe reformulate this? That's pretty clever. If the digits match, then the streak increases. If the digits don't match, then store the previous streak in your next digits array, create a new streak, and then finally, after you finish parsing through the current your last streak of digits is going to be needed to append to the next digits, and then just change out which your next digits for your digits. All right, time complexity. This is going to be kind of like O of n squared. Well, n is constant. Well, n goes up to 30. N goes up to 30, which is kind of constant. No, that's O of n. I want to say this is O of n. Depends on how you want to consider the length of the strings that you're dealing with. The length of the string is capped to be kind of the length of n, I want to say. Actually, I don't know. This is not sure, but at least that. I guess O of n would be like how many times you do the loop, but then each loop you have the size of the current string, which I'm not sure. Not sure how the length of the string for some level of n is related to n. Could be O of n squared if string is proportional to string length is proportional to level. And then space complexity, again, this is unsure. But at least O of n.